record so that I can be official now. What I want to say is, number one, your test scores have been entered into Moodle. I am not physically handing them back until class on Wednesday. The reason being is there were a couple people out for prearranged medical things, and so they are getting the test done today, and then I would say, well, I'll hand it back in class tomorrow, but tomorrow's election day and we don't have school tomorrow. So if you want to know how you did on the test, you can go into the Moodle page right now or whenever it works for you and check that out. I will just say, as always, 90 and above is an A, 80 and above is a B, 65 and above is the low C in this class, and 55 and above is the low D in this class. If you just missed something by a couple of points, my hope is that you've now gotten the feel for me that a few points is not going to stand in the way of a grade at the end of the semester. That's just not the sort of person I am. And also remember that while each test is worth 20% of the grade, in the end, no one test affects is going to really do a whole heck of a lot in terms of ruining somebody's grade. Okay, so anyhow, I just wanted to make everybody aware of this. I did get the, so yeah, Saturday I planted garlic, did firewood, and then when it was cool in the evening, I graded, and then I graded first thing yesterday morning to finish it up. Once I saw that there was 24 inches of snow, I'm like, I'm going to go ski today, so I'm going to get my grading done really, really fast. Anyway, so yes, on top of that, I did get the test graded. All right. And we can talk more about the test when I return it. But what I want to say now is we are now starting the final portion of this class. Okay, we have just one more group of sections to go through. I'm gonna share my screen really quick with the MyOpenMath. So just so that you know, we have all of these different units. We have unit 4 left to do, and then unit 5, but I just do this as one online homework assignment. So really, we don't have a heck of a lot more. We have 1, 2, 3, 4. Essentially, you have 5 more homework assignments for this class, because lessons 16 and 17 are, I just made into one assignment. Okay. So we, after that last test, we finished our units on probability and statistics. Now we're going to do something totally different and go and talk about linear math. Okay. We do this portion of the class for anybody who's a business major. This sort of material is really important for people who are going in and studying business, whether it's accounting, whether it's management, what have you. These ideas are super important. Okay, so those of you who are going into social sciences, not as relevant, but just sit back, enjoy the ride, and enjoy the math, because it is kind of cute math. Now, this is a portion of the class that does rely on you remembering a little bit about some algebra that you may have learned in your past. Okay. What I'm going to say to you is, if you find that you have tremendous gaps in your knowledge, don't freak out. I have a free online program that I can enroll you in that will help you fill in any gaps, okay? In particular, we're going to be talking about like finding equations of lines and finding slopes and graphing lines and that sort of thing, okay? We're not going to get really heavy duty into it. I will go through and do a review just to be sure that we're all on the same page. But if you find that you need a little bit more background help, please feel free to send me an email and let me know. Okay. All right. So here we go. Oh, phew. Okay. I was like, wow, this is a big group. I don't know that I have time to complete this semester, but then I realized it was more than. Okay. So lesson 12. We are going to be talking about lines. In this section, we're going to be talking about equations and graphs. Okay, this is fundamental for what we're going to be doing for the rest of this semester in terms of the math. Okay, so one of the things, again, that I would like to just mention, and my hope is that you're familiar with it. This is called our Cartesian coordinate system. Descartes is the one who came up with it. So in our Cartesian coordinate system, what it allows us to do is graph things in 2 dimensions. So we were talking about various things on the number line when we were dealing with our normal distributions. Well, now we're going to be in 2 dimensions, and we have what we call an x-axis, or our horizontal axis, and our y-axis, which is called our vertical axis. Okay, and you can think of your x-axis very similar to the number line. Okay, right here, this is what we call 0, and then as we move to the right, our numbers get larger. As we move to the left, our numbers get smaller. And so you can think of the x-axis as your number line. Now, similarly, we have our vertical axis, or our y-axis. And fortunately, it's kind of intuitive that if this is 0, as you go up, your numbers go up. And as you go down, your numbers go down. And it keeps going infinitely in all 4 directions. Okay, so just a couple side notes about your Cartesian coordinate system. Notice that these 2 perpendicular lines separates our space into 4 different regions. Okay. There's names for these. This isn't something that we're going to get really detailed into, but these things are called quadrants. We start here with quadrant 1, and then 2, 3, 4. Okay, we go counterclockwise precisely because when we deal with trigonometry, we go this way. All right. Now, the way we identify points in this Cartesian coordinate system is we identify them as ordered pairs. They're called ordered pairs, which tells you implicit in this name, order matters. Okay, your x value always goes first, your y value always goes second. Okay, the way I want you to think of your x value is it tells you how much and in which direction to move horizontally from this point here, which, by the way, is the ordered pair 0, 0, and has a name called the origin. Okay, so your first value tells you how much to move left and right, and then your second value tells you how much you're moving up and down. So for example, and I'm going to assume that you know how to plot points. If this is a tough issue for you, this is certainly a situation in which you want to email me and say, yo, Lauren, please enroll me in that program. Okay. If you want to plot the 0.31, what that tells you is from your origin, you move in the positive direction 3, and then you move vertically up 1. And we like to label our points. Okay. Another point, just to be sure we're all on the same page, how about -2, 2? Okay, from my origin, where do I go now? Good, I go left 2, and then do I go up or down 2? Up 2. And finally, what about 2, -3? So where do I go for my origin for this guy? I go right 2 and then down 3. Okay, 2 other points that I want to plot because they're special. Oops. How about this one right here? What does this x equals 0 tell me? Do I move to the right or to the left? No, I stay put, but what do I do from here? I go up 4. Notice that this point when x is equal to 0 lives on my vertical axis or my y-axis. How about this point -3, 0? What do I do here? I go left 3, and do I move up or down? No, I stay put. Notice this is also a cute little interesting point because it lives on my x-axis. In fact, those are such cute and interesting points that we have names for points like these that live on either our vertical or our horizontal axis. These things are called intercepts. Intercepts are very, very useful things in algebra. Now, I want to say that we're not going to get really deep, nitty gritty into a lot of algebra. This is not an algebra class. Okay, we're going to be doing some of this stuff, but it's going to take mostly an applications-based thing. But intercepts are important. And what I'll tell you is, for example, if I had a line that went through this point, it's where the graph either touches or crosses each axis. Now, I will say we're not going to do anything in this class graphing wise other than lines. Okay, so don't worry about exponential functions or anything like that. Okay. So to get specific, what I'm going to say, and these are very important things for you to know and to use in practice. An x-intercept is where the graph either crosses or touches the x-axis. And what I want to point out to you is as follows. Okay, so -3, 0 right here would be an x-intercept, for example. Okay, another x-intercept would be right here. What would this ordered pair be written as? Be careful it's 2, 0, isn't it? Notice any of these points on my x-axis, my x values can take on infinitely many different values, but what is always true when I'm sitting on my x-axis? Beautiful. no matter where I am, when I'm on my x-axis, my y value is always 0. I have not moved up, nor have I moved down. Okay, so my x-intercepts always have the form x comma 0. Now, when we're given an equation of something and we want to find our x-intercept, this gives us a way to find our x-intercept. It says, okay, set y equal to 0 and solve for x. And I'll get to where we're going to be interested in that soon enough. Okay. Now, in a similar manner, I have a y-intercept, and that's where the graph either crosses or touches my y-axis or my vertical axis. So in a similar manner, let me ask you a question. What is true no matter where I am on my vertical axis? Beautiful. I haven't moved to the right, nor have I moved to the left. So I claim no matter where I am on this axis, my x value is always here. So our y-intercepts have the form 0, comma y. And again, if we're given an equation of some function and we want to find our intercept, this also gives us a strategy. Because to find our y-intercept, by definition, it's the value of y when x is 0. We'll set x equal to 0 in the equation and then solve for y. Is this somewhat familiar to you all? Or at least is it coming back? Those of you on Zoom, are you all okay?
Yeah, I think so.
Cool. Hey, as long as so far we're cool, this is great. I mean, it's my goal to teach this so that we start at the ground level and move on. Okay. So please, please let me know if you have a question. Okay. So another thing that we like to talk about, and you're like, wait, you can't wait until math people are done talking, right? Okay. All right. So another thing that we like to talk about in terms of this Cartesian coordinate system and the fact that we're only going to be dealing with linear equations, we like to talk about slope. And actually, I like to talk about slope a lot anyway, because I love playing outdoors. So as I mentioned, those of you on Zoom, I mentioned to the class, the folks who are in the class right now, that there were 24 inches of snow yesterday up at Lost Trail. So I went skiing yesterday and it was a total blast. So again, my legs got reminded of slope in a different way than just my running lets my legs get reminded of slope. So when we talk about the slope of something, what we're doing, and we're going to be talking about the slope of lines in particular, what this does is it measures the steepness of the line. Okay. So for example, and we're going to practice calculating our slope. Don't worry, I'm going to guide us through everything here. But I kind of want to give you the idea behind it because I could just give you the formula. But I think the formula has more meaning when you actually see where it came from. Okay. So again, we always read our graphs from left to right. I could talk about that hill, and I could also talk about that hill. So let's pretend that I'm walking, running, skiing, biking up these hills. Do you all agree that walking up this hill would have an extremely different sensation than walking up this hill? Yeah. Okay. So we would say that this is steeper than this. Well, how do we mathematize steepness? Okay. Well, essentially what we say is as we go from one X value to another X value. In other words, as I'm moving, in this case, to the right. Here, so as I'm moving this horizontal distance, what I'm asking is how much does this vertical distance change? And I think you'll grant me that in this situation, as I move this horizontal distance, I have a pretty big change in my vertical distance. Whereas in this line, as I move over this horizontal distance, there is a change in my vertical distance, but it's certainly far less significant. We call this rise and we call this run. Okay, so when we're talking about the slope, what we're saying is as we move over some horizontal distance, what is the vertical change? So really what we're doing is we're looking at a ratio. A ratio means a fraction. So when we talk about the slope, we use the letter M for that. And I'm honestly not sure where that came from. I always think, oh, I should look that up. And then I forget. But our slope is the ratio of rise over run. Okay. In other words, as we run a particular horizontal distance, we wonder what is happening to our vertical change. You with me there? Now, we can also cruise downhill. That's always really fun as well, right? And we could also talk about, the slope of horizontal lines lines that are decreasing as well. And we'll see the difference in what our slopes look like if our lines are increasing or if they're decreasing. But what I want to do right here is attempt to draw a picture. Let's just say this is our line. And I'm going to say this is my first X value and this is my second X value. And this is Y1 and that's Y2. So what I want to say to you all is this ordered pair I'm going to write as X1, Y1. And this ordered pair I'm going to write as X2, Y2. Okay, the 1 and the 2 just differentiate those points. Okay, so these are two different ordered pairs. So if we want to talk about the slope, what we want to do is look at the ratio, again, of our rise over run. In other words, what is the vertical change as a ratio of our horizontal change? Well, can we measure this vertical distance here? I claim that we can, right? I claim from here all the way down is Y2, right? That's this entire height. But we don't want this portion down here. What is this height here? Y1. So we'll subtract it off. And similarly, we can measure what this horizontal distance is. This whole horizontal distance here, I claim is X2, but we only want it from here to here. So what we need to do is subtract off whatever this distance is. And what is that distance? X1. And this is what gives us the formula for the slope. Okay. The way I think of it is it's the change in Y values over the change in X values. Most common mistake people make is they bebop these. It's not run over rise, it's rise over run. Okay, again, you don't need to memorize these things. You get a sheet of paper with notes, but it's good to have that kind of second nature. And my guess is it will be once we play with sufficient number of examples. So I thought what I would do right now is just make sure that we're all totally cool with finding the slopes of lines. So what I'm going to do is I'm going to find the slope of 4 different lines. Okay. Not because I don't think that you can do these things on your own, but because I want to point out patterns. Okay. Patterns are a great way to check yourself. Are you ready? Cool. All righty. So what if I want us to find the slope of the line containing this point and this point? Isn't this a nice Monday morning thing? Relatively, I mean, given that you're in math class, isn't this a nice Monday morning thing? See how it helps to reduce our sample space? You gotta love conditional. Okay. Now we could plot these points if we wanted to see what this line looked like. We don't have to. Note we weren't asked. But 8, -1 means we move right 8 and down 1. And 4, 3 means that we move right 4 and up 3. Ooh, this is a line going down. Okay, now the most common question people ask is, which ordered pair do I let be x1, y1, and which ordered pair do I let be x2, y2? And my answer to you is it doesn't matter, okay? And I'll show you in this one example that whichever way you go, you're gonna get the same thing. The key thing to keep in mind is whichever y value you start with in the numerator, you got to start with its corresponding x value in the denominator. Okay. So for example, if I started with this y value, I would say I have 3 minus a -1. Okay, so since I started with 3 in my numerator, I'm going to start with 4 in my denominator divided by 4 minus 8. Okay, if there's a question, don't be shy. Please ask if you're on Zoom, on mute, whatever you need to do. Notice minus a negative is plus a positive. What's 3 plus 1? 4. What is 4 minus 8? -4. What is 4 divided by -4? -1. Now, suppose you were like, Lauren, I really wanted to start with this -3. I'll tell you that you're going to get the same thing. Or -1, sorry. It would help if I knew my numbers. If I started with the -1 here, do you agree I'd have -1 minus 3 in my numerator? But then since I started with this y value in my numerator, who do I need to start with in my denominator? 8. Well, what is -1 minus 3? -4. What is 8 minus 4? 4. What is -4 divided by 4? -1. Notice we got the same thing either way. Okay, again, here the negative was in the denominator, here it's just up in the numerator. Okay, notice I have a negative slope. Notice as I'm moving from left to right, my line goes down. Questions on this one? Let's do another one. What if I want to find the equation of the line passing through the points? I don't know, -3, 5 and -4, -3. May I not have to climb this hill? And if you're wondering, why do I say that? Check this one out. If I plot -3, 5. And then -4, -3. Look how steep that line is. Right? Okay, doesn't matter which y value we start with. Who would you like to start with? -3 or +5? -3. All righty. So I'm starting with -3. So then I subtract 5. Change in y values. But since I started with the -3 in my numerator, who do I need to start with in my denominator? -4 minus a -3. Change in y values over change in x values. Well, what's -3 minus 5? -8. And -4 minus a -3 is -4 plus 3, which is -1. So we get a slope of 8. That's really, really, really steep. Just saying. Okay, so notice I have a negative slope. My line went down. I have a positive slope. My line, as I move from left to right, is going up. What if I want us to find the slope of the line containing these points? 3, -5 and 2, -5. So like I said, if you didn't remember finding slopes, we're certainly going through a lot of examples. Well, who should we start with, -5 or -5? Tough decision, huh? How about we start with this -5? So if I start with that y value, I have -5 minus that -5. Isn't that divided by 2 minus 3? Well, minus a negative is plus a positive. What's -5 plus 5? 0. What is 2 minus 3? And what is 0 divided by anything? 0. Huh. Well, that's kind of interesting. We just got a line with no slope. Aren't you curious what that line looks like? Well, we can plot these 2 points and play connect the dots. Here's 3, -5, and here's 2, -5. What sort of line did we get? Didn't we get a horizontal line here? And it makes sense. If we were cruising along this line, there is no slope, is there? So this is like being in Chicago. I'm from Chicago, so that's why I always think of the Midwest with no slope. All righty. One more. What if I want us to find the slope of the line containing the points 2, 1 and 2, 5? Well, let's find our slope. Should we start with the 1 or the 5? 5, okay. So I'm going to have 5 minus 1 in my numerator. And since I started with the 5 in my numerator, I got to start with its corresponding x value in my denominator, which then gives me 2 minus 2. What is 5 minus 4 or 5 minus 1? 4, sorry. What is 2 minus 2? 0. What is any number divided by 0? It's undefined. Division by zero is illegal. The math cops will come and try to take you away, which isn't a terrible thing because it just means that you just get to do math all the time. Do you want to see why division by zero is undefined? I mean, you could put it in your calculator and you're going to get an error message. This is a side note, but I like showing why things are true because so often you're told it's true and it's like, okay, why? Well, let me ask you this. First off, let me tell you this. Division is the inverse of multiplication, just like subtraction is the inverse or the opposite of addition. Okay, so if I wanted to know 16 divided by 8, I would say that's equal to what? 2. The reason why is because 8 times 2 gives me 16. If I wanted to know 24 divided by 6, I'm asking, well, what number do I multiply 6 by in order to get 24? And what are you going to tell me here? 4, right? That's equal to 4 since 6 times 4 is 24. If I wanted to know what's 0 divided by 7, well, 7 times what gives me 0? 0. Okay, so that's equal to 0 since 7 times 0 is 0. Well, now what if I asked what is 7 divided by 0? Well, that would have to be equal to some number x, where 0 times that number is 7. Is 0 times any number ever equal to 7? No, no such number exists. Because what's 0 times anything? 0. That is why it is undefined. Now, you might be like, well, wait a minute, Lauren, what the heck does a line with an undefined slope look like? Well, guess what we can do? We can plot these points, connect the dots, and see what it looks like. Well, I can plot 2, 1, and I can also plot 2, 5. And what type of line do we get here? This is a vertical line. That's called free fall. So in sum, what I want you to take away from all of these examples that we just did is if as you move from left to right, your line goes up, you have a positive slope. Remember, positive says greater than 0. If as you move from left to right, your line goes down, you have a negative slope. If you have a horizontal line, your slope is 0. And if you have a vertical line, your slope is undefined. Is this okay so far? All right, those of you on Zoom, how's this so far?
Good.
Okay, cool. All righty. So my hope is that you're now going to trust that I'll guide us very gently through this stuff. Okay. So now what I want to do is like take this feel and use this idea of slope. And we're going to start playing with some graphs. Okay. First off, you don't ever have to buy graphing paper for this class. If I ever ask you to graph something, on the test, there would be graph paper on it. Okay, so as with everything else in my philosophy of this class, save your money unless you like to do art, in which case maybe graph paper is just kind of a fun thing for you to have anyway. Okay. So what if I wanted us to do this? And if you're like, whoa, not sure, well, this is why I'm here to talk about it. Okay. What if I want you to graph the line passing through a particular point, and this particular point is going to be this ordered pair with a slope of 2/3. We'll get into finding equations of lines later. But I claim what we're going to do here is just going to continue to give us a good feel for the slope. Now, whenever you are asked to graph a line and you're given a point and a slope, I'm going to tell you, start here. You want to graph that point. Okay? Well, if I graph my ordered pair -1, 2, that means I move left 1 and up 2. So do you agree that that's my starting point? Now, very literally, from this point, we're going to use the idea of slope being 2/3. Okay? Remember, our slope is 2/3. We can think of our slope as rise over run. So literally, what this tells us is we're going to, from this point, rise 2, in other words, go up 2, and then run 3, i.e. move over 3. Okay, so from this point right here, I go up 2 and over 1, 2, 3. And then I play connect the dots. And I got it. Notice this makes sense. We have a positive slope. And as we're moving from left to right, my line is going up. Ready?
Hey, Lauren,
Yeah.
did you start on the 0.00?
No.
Okay.
You start here, like literally from here.
You go
I'll
up
write
to.
that out. From here, use the slope. Does that help?
Yeah. So is that? I just thought it would be on. Wouldn't it be on 2 instead of 3 then, or no?
We would go up 2 and over 3 from this point.
Okay.
So if I go up 2, I'm right
Yeah.
here. And then if I go over 3, I'm at 1, 2, 3.
Okay.
So
Thank
we
you.
would be at the 0.24. But notice, or excuse me. Yeah, sorry. Notice if we're going right 3, I would be from -1. If I add 3, I'm at +2.
Yeah. Yeah. Okay. Never mind. I see.
Okay.
I didn't read the point. I thought it was above the 3 instead of the 2.
All right, let's do one more just to be sure. What if we want to find or graph the line? How about passing through? I don't really care. How about 2, 0 with a slope of -1/4? Again, what we're gonna do is start here. You with me this far? Now, what does the slope of -1/4 mean? Well, with -1/4, I mean, there's three different ways you can write that. You could write -1/4, -1/4, or 1/4. These are all equivalent. I tend to always throw my negative in my numerator. That's just the way I tend to think of it. So what do you think on an intuitive level it means to rise -1? Good, you go down 1 and then over 4. So from here, if I go down 1 and then over 1, 2, 3, 4, and then play connect the dots. Now, those of you who would be like, I want to throw my negative in my denominator, you can do that. But then if you interpret this as rise over run, you're saying up 1, but now left 4. And I claim it's still going to be on the line. Because if you go up 1 and then over 1, 2, 3, 4, well, it's still on that line. Yeah, okay, just want to be sure. All right, I'm going to pick up here next time. Hey, I hope you all have a great day off tomorrow. Please be sure you vote. This is something that we should be proud of as Americans, that we have the ability to vote. So I encourage everyone to do that and to have an awesome day. And I will pick up from here on Wednesday. See ya.